Okay, so we are joined here today by Amr Ghazal, a team member of iGEM Lund. Thank you for joining us, Amr.
Thank you for having me on your podcast, Victor.
Can you tell us a bit more about yourself, maybe?
So I'm almost 21. I grew up in Romania, and then I moved to Lebanon, where my parents are from, and that's where I lived my teenage years up until last year when I came to Sweden. And I study. I'm in between studying physics and mathematics, and studied chemistry for 2 years before that. So yeah, that's a little bit about me.
Okay, nice. So we are obviously part of the same iGEM team, but for those who aren't involved in our project, can you maybe explain what it's about?
So we're working on a synthetic biology research competition, where we're designing and altering bacteria to our benefits. In our case, we're altering a certain strain of E. coli bacteria and modifying it in a way that when we consume it and ingest it, it will absorb the heavy metals that are in our gut microbiome. In simple words, this means that when we eat this pill or this bacteria, it will absorb the toxic metals that are accumulating in our bodies and prevent them from doing so.
Okay. And how are you going to achieve this?
We're gonna alter the bacteria E. coli niso, and by doing so, it will enable the bacteria's innate ability to absorb toxic metals. So once this bacteria is in our system, it will do this job basically.
Okay, so you're like altering the genes to your benefit, basically.
Yeah.
Okay. And you said earlier that you're from Lebanon, and from what I understand, that is supposedly one of the countries where heavy metal contamination and poisoning is a big problem, right?
Yes. Now it is very the levels of heavy metals in our products, water, and generally ecosystem are very high, except that there is no general public knowledge about it. Like we have to wash our vegetables a lot. We have to make sure not to drink the tap water, make sure to avoid a lot of things because we have knowledge that it's toxic. We don't exactly know how or what is toxic about it, but all we do know is that it is. Now, I was actually curious a few weeks ago about this topic. So I checked scientific articles and I just wanted to know what numbers are out there to see how real this issue is. And it turns out that the levels of heavy metals fluctuate between 1 to 3.5 micrograms of mercury per gram of vegetable, which for someone who doesn't know what these numbers are, it's very toxic. It's very dangerous, and unless you wash it like a couple of times, then your level of contamination is really, really high.
Mm. Are there any like recommended levels of intake, or not recommended, but maximum limits?
If you go for arsenic, the maximum limit put by the World Health Organization is no more than 30 micrograms per liter. So for people who are ingesting, let's say, 500 grams of unwashed vegetables that are contaminated with arsenic and mercury, they are getting about 150 micrograms of toxic metals, which is way above the limit of what your body should consume.
Oh yeah, scary things. But what is the root cause of this problem? Like, why are countries such as Lebanon so heavily affected by this?
Now, in the case of Lebanon, we have a lot of industries that just throw their waste into the water that don't. There's a lot of loopholes in the law itself that just allow these companies and these industries to avoid paying a lot of money at the cost of harming the environment. So what ends up happening is that the companies will just ignore the regulations. They will just ignore the harm that they're causing, and they will just throw their waste into the water. And besides that, we have a lot of a lot of different contaminations, such as biological redistribution and just generally not having proper regulations that cause these contaminations.
Oh, and are most people aware that this is actually a serious problem?
Now, they are aware that the law is outdated, but I mean, people can't do much about it. There are a lot of organizations that are trying to change it. There are a lot of outreaches and a lot of sort of efforts being done to change that. But and so far, it's still at it still benefits the companies where they can just avoid all that stuff and throw their waste into the water and their chemical waste and pollute it, basically.
So this is for sure a problem that needs to be emphasized more.
Yeah.
How did you come up with the idea to go for heavy metals and try to come up with a method for preventing diseases caused by it? Like there must have been so many options to go for.
In the iGEM team, you mean?
Yeah, like when you brainstorm ideas and stuff.
Yeah. Now, when we started brainstorming ideas, we had a couple ones out there. And then when we thought of heavy metals, we were like, oh yeah, heavy metal, because it struck a nerve basically in all of us. I mean, we've all heard what heavy metals are, and we've all had an idea that, yeah, so when a thermometer breaks, don't come close to it. So like avoid any contaminate, like avoid lead contaminated water at all costs. And we all have had like certain previous knowledge about it. So when the topic came up, we all kind of got excited for it. And at first we thought of setting up a filtration system. But then after consulting several professors and experts in the topic, they suggested that we try to counter this problem intravenously and starting in our bodies, which is where basically we got the idea, okay, so let's try to engineer a bacteria that removes the heavy metals from our bodies.
Yeah, so besides from the pure science part of the project, there is so much more to it, to the iGEM project, like integrated human practices, finances, and so what else besides the science part are you doing?
We've been working and are still working on several projects. Not too long ago, actually, two people from the iGEM team went to Stockholm and participated in a science summer camp and taught children synthetic biology. Like they performed basic experiments, and then they told them about our project, and the students were really interested and curious about what heavy metals are and how they work, and synthetic biology just in general. Apart from that, we are working on bioethics projects. We're working on this podcast in particular to help share different ideas between people from the iGEM team and other iGEM teams and like just general public. And we have a lot of set ongoing projects that we're gonna start with as soon as we have some physical data from the experimental procedures.
Awesome. How did you first become interested in iGEM? Like you said, you were studying physics and some chemistry and mathematics. Like how did you come upon this project?
Yeah. So the whole concept of synthetic biology is very new to me in general. I did not know that anyone could just alter the bacteria or the DNA, that you can change its function and basically create something that didn't exist before and have it help you in a certain way or another. And well, to me, that's basically the root of it. I wanted to learn more about this domain and this topic and see how it can be implemented and integrated into daily lives. Because, I mean, starting with me, I had no idea that such a thing existed and like how it can be used and how it can be implemented. And now, a few months into doing more research and learning more about it, I am learning, okay, so we can make this bacteria that potentially it can remove harmless toxic metals from your body and like help save you from poisoning in a few years. So this whole concept can be very beneficial publicly and just scientifically in general. Now, of course, what's very special about iGEM is that it spreads the word about synthetic biology. It's not limited to the science itself, but it teaches how to communicate the science that you're doing in the lab. So eventually, when you have an end product that can do something beneficial in any sort of way, you have already established grounds on how to communicate it publicly and how to spread this sort of information. Because I mean, information that no one knows about or no one accepts is useless. So if we can't reach out to the general public and people in need of, let's say, this sort of bacteria that can help them protect them against something or another, then it isn't that much it isn't that beneficial just to discover something. So what's really nice about iGEM is that it covers all aspects of discovering, finding, changing, and communicating your findings to everyone else out there, and in a way that, well, they'll believe you and they'll see that, oh, this works, and yeah, I can implement it into my lives. I just need to change my attitude and perspective about it, maybe. So yeah, it's very interesting.
Is it something you would want to keep working with when you're like later on in life?
Probably, but not sure yet.
Hard to tell, maybe.
Yeah. Yes.
So it's time to wrap this up. Thank you so much for joining us, Amr. It's been great having you here.
Thank you so much for having me, Viktor.
Yeah, nice.